Okay, guys, we're going to go ahead and move on to section 1.2. And we're talking about domain and range. And domain and range are just, we're continuing talking about functions, but now we want to start defining and getting some terminologies that helps us talk about those a little bit more. So domain and range, the domain is the set of all the possible input values for the function. So all those usually x values that we were looking at, if we could list all those values, that is the domain of the function. Okay, so it's all the possible input values of our function. And as you may guess, the range then is going to be the set of all the possible output values of the function. So input values, remember, are typically the x's, and then not always, but depends on what letters they're using. But when we're talking about graphs, usually these are the x's, and then these are the y values. Okay, so that's domain and range. So we've got a couple different types of notation, and I'm going to focus mostly on the second one, but I do want to mention the first one because it does pop up every once in a while. The first one is called set builder notation, or sometimes just set notation, people will call it. And here's what this always looks like. You always have these braces on either side, which are kind of like squiggly parentheses or pointy parentheses or something like that, but they're called braces. And then you'll always have a variable here. And that variable tells you what letter you're talking about. So in this case, we're talking about x values. And then you're going to have this vertical line after that, and then it will give you the conditions. So they're saying it's the set of all the x's with this condition. And the condition is that 10 is less than or equal to all the x values, and the x values are less than 30. That's the condition to be in that group. Okay, so numbers like 22 would be in the group, or 10 would be in the group, or 29 would be in the group because it fits into this condition. Okay, now if you're checking 60, 60's out here bigger than 30, that's not in the group. Okay, so this part is just telling you what x values are we actually talking about. Okay, and again, the way we read that is the set, that's because of these braces, the set of x values such that, that's what this little vertical line, technically how you say it, such that is less than or equal to x, and x is less than 30. So pretty much what I said, but that's how you would write it out if you needed to write it out. So that one we don't use as much, set notation, but it does pop up every once in a while. The one that we will use most of the time is interval notation. And interval notation is written like this. You always write down the endpoints, the far left-hand value, the lowest value, and then the highest value of your interval. You do that first with a comma in between them. And then on the outside, you put down grouping symbols. And those grouping symbols are either parentheses or they're brackets, one or the other. So the endpoints are listed, and parentheses are listed for open endpoints, and brackets are used for closed endpoints. Okay, so here's the same example. Notice the 10 and the 30 are the two endpoints. That was the lowest and highest value. The 30 gets a parentheses because it's open. That means the 30 is not part of the group. It's just the boundary for the group. Okay, so that's, you're saying x is less than 30. X is not equal to 30 is not part of the group because 30 is not less than 30. Does that make sense? Okay. And then this one, 10 is less than or equal to x, means 10 is part of the group because 10 is equal to 10. So that means it is part of the group because of this symbol right here. So this part right here tells you this is closed, and that tells you brackets. This one right here, because there's no equal sign underneath it, tells you that it's open, and that tells you that this is why this is parentheses and this one is brackets. Okay, that's the difference between the two. All right, but you only ever write those two numbers with a comma, and then you put your whatever appropriate grouping symbols would go there, either brackets or parentheses. Okay. Any questions on that before we go on? I think the next thing is just a bunch of examples of it. So Yeah, so if there's extra stuff on your notes, just cross it off. We're doing those right now. I think this is where I had some, maybe extras. Okay, so if we're talking about an inequality, so this says 5 is less than h and h is less than or equal to 10, we're going to talk about the couple different ways you could write it. Notice in set builder notation, all you do is you put the braces and the h, and then you just copy this down, right? On every one of these, put the braces, the h, you just copy it down. All of those, they're all just copied down, right? Does that make sense? So in that way, set builder notation is maybe easier because you just copy down what you already have for the inequality. But in interval notation, notice again what we have. We've got the boundaries, 5 and 10. 5 and 10. The one without the equal sign gets a parenthesis over there. The one with the equal sign gets a bracket. Okay? And the smaller one always goes first, and the bigger one always goes second. And I emphasize that because in the computer on the homework, if you put the bigger one first and the smaller one second, it's going to count it wrong because the small one has to go first and the big one has to go second when you're putting your two boundaries. Okay? So again, boundaries 5 and 10. This time the 5 gets a bracket and the 10 gets parentheses. So it doesn't matter which side, parentheses, brackets, it doesn't matter. Just whichever one has the equal sign gets a bracket. Whichever one doesn't, parentheses. In this one, notice neither of them have an equal sign, so they're both parentheses. Right? You could also have both brackets. I guess I don't have an example like that, but they could both be brackets if they both had equal signs. So all different combinations of those parentheses and brackets. So here's the ones that maybe are going to be a little bit new to you. If we have h is less than 10, so if we think about a graph, here's our 10. And if you remember graphing these, the less than means it's an open circle because it's not included. There's no equal sign there. And our graph is saying everything less than 10, which means it's everything over here to the left. And you're going forever to the left because that arrow just keeps going. Okay? The way we write that with interval notation is we have an upper boundary, 10. And so that's this number right here. That's the upper boundary because it's the furthest to the right. There is no lower boundary. The way we represent going forever to the left is this negative infinity. That sideways H shape, that's infinity. So negative infinity means we go forever to the left. Okay? Now, this one is parentheses because there's no equal sign by it, right? And the infinities, make note of this because I'll probably say it 5 more times tonight. Infinity, I may say more than that. Infinities always get parentheses. There's never a bracket there because there is no end to try and include. It goes forever. Just keeps going and going and going. So you can't stop and say, well, this point is included. It goes past that and keeps going further. Okay. Notice this one. This one would be 10 is the boundary right here. Closed circle, that's why they call it a closed interval. And this one's going to the right. So this time 10 is the lower boundary, right? It gets a bracket because it's or equal to. And then it goes forever to the right. And the way we represent that is infinity. And again, infinities always get parentheses. Every time. And then the last one, all real numbers. That means you want to include everything to the left and everything to the right forever. So you have no boundary on the left, you have no boundary on the right. So the way they write that in interval notation is negative infinity to positive infinity. And again, infinities always get parentheses, so they both get parentheses. And then here you probably haven't seen this one maybe for a while, but this symbol right, well, actually there's 2 symbols that I need to explain. This one, it looks like a kind of, I don't know what that looks like, a backwards 3, kind of. That's the symbol that means is an element of. And then this double bar R, fancy R, means all real numbers. So it just means H is some real number. It's in that group of real numbers. This one, I don't think, and I've taught this class for a lot of years, I don't think we actually use this. We switched it over about 3 years ago. I don't think we use that in this class. I don't think we use the double bar R, but that is how you write it. So. Okay, so that's a bunch of different examples. Are there any that you want clarification on? Does it make sense? The bracket means equal to. The parentheses means not equal to, and infinities always get parentheses. So any questions there? All right, we're going to do some more examples of them. Oh, first we have to talk about how we combine them, because sometimes we don't just have one group, we might have two. So to combine two intervals together using inequality set notation, we just use the word or. So maybe it's in this group or it's in this group. Just put an or in between them. If we're using interval notation, we use the union symbol, which still means we're putting the two groups together, but it's just like a big capital U in between the two groups. And we'll show you how to do that. And it combines the two unconnected intervals together. So the population of a small town in the year 1960 was 100 people. Since then, the population has grown to 1,400 people reported during the 2010 census. Choose descriptive variables for your input and output and use interval notation to write the domain and range. So which pieces of information here would you consider the input? What do you think? And remember, input is like the one that determines the output. What do you think that would be?
1960.
Yeah, it's the year. 1960. Does that make sense? The year, you find the year and then you count the people. So the year determines what the output is going to be. So 1960, the input will be the year. The output then is what? The population, the number of people. Okay, and most of the time when you're dealing with time, it's going to be the input because you're kind of paying attention to something as time goes by. So the time is the input and the resulting numbers are the output. So if we're going to talk about our domain and we're going to use interval notation, we want the lowest value for the interval notation or for the interval and the upper value for the interval. So what's the lowest value for our input for our years? 1960, right? So I'm going to put that first, and then I'm going to put my comma. And then what's the upper value? 2010. Okay. Now the second thing we have to do is we have to deal with our grouping symbols. So do you think 1960 is included in the interval? Would there be an equal sign there or not? And then the same question with 2010. What? Two what? I'm sorry, say that again.
Would there be one for each year?
Yeah, there'll be one. Is that what you're asking? One grouping symbol on each side? Yeah, it'll be one grouping symbol on each side. And so we want to determine which one is it for each one of those. So here's how you can figure it out in a case like this. Can you tell me the population in 1960? Yeah, they're saying this is the population in 1960, right? It's not part of the boundary. This is a value in our group, right? So they are including 1960 in that group. That's a bracket. And kind of the same question on the other side. Can you tell me the population in 2010? Yes. So we know that value. They told us this value. So this is included also. Does that make sense? And again, on time ones, it's usually going to be included with time because you have to know when you're starting and what the starting value is and different things like that. Okay, now for the range, remember this is the outputs. So this is the population. And again, we start with the smallest. What's the smallest population that we have here? Yeah, 100. And then the biggest one? 1,400. And do you think these should be parentheses or brackets? Was there a time when there was exactly 100 people? Yes. The year 1960. So yes, equal to 100 is the smallest. And what do you think about the other side? Was there a time when it was exactly 1,400, at least according to the data we have? Yes. So bracket there too. We weren't saying it was less than 1,400. We're saying it at this point it was equal to 1,400. Does that make sense? Equal to means bracket. So that's how we would do that. That's how we represent these things with interval notation. Questions there? All right. So what if we're looking at a graph? Describe the intervals of the values shown on the line graph below using set builder and interval notation. So I'm going to start with interval just because we were kind of practicing it already. But notice we have two separate sections to our graph, right? That's where that union symbol comes in because we've got two separate sections to talk about. So looking at this first one in interval notation, what's the lowest boundary and the lower and upper boundary on this one? 1 and 3, right? So 1, 3. Now, we kind of mentioned it already, but just to double check, is this one going to be a bracket or a parentheses? I'm not sure. I heard a lot of things, but I'm not sure that I got any of them actually coming to my ears. This is a bracket, and the reason is because the filled in circle tells you that one is included. It's like an or equal to sign. So this is, again, because of the filled in circle, that's going to be a bracket, whichever way the bracket happens to go. It should go the other way on that one. But so what's going to happen on the 3 also? Bracket. But then we want to talk about this other area over here. And what's the lowest value over here? 5. And then because it keeps going forever, what do we put after the comma? Infinity. That means it goes forever in a positive direction. And will the 5 get a bracket or parentheses? Parentheses, and why? The open circle tells you parentheses. It's not included. So parentheses. And what did I say about infinities? They always get parentheses. Okay? Now, this is where we're putting these two together. So that's where this union symbol comes in. And when you're entering that on the computer, there's a section that says, I think it says, like when you go to enter your answer, a drop-down menu comes up and it says like basic something and interval. So all your symbols for interval notation are in that interval drop-down menu. Okay, and again, if you get stuck on that, either talk to somebody else or ask me or whatever, and we'll get you fixed up. So that's interval notation. Set notation or set builder notation. Remember how we do this, and we're just going to assume these are x's. So I'm just going to say the set of all x's, and then our condition. We always start out like that. If we're talking about x's, since they go horizontally, we're going to say they're x's. What's the conditions, or how would we write this first one? Now, visually looking at it, do we see that x has to be between 1 and 3? Does that kind of make sense? So it actually, we write it that way. So 1 and x and 3, and we can see 1 is between those two because it has to be between them. So here's the symbols that we use are always less than sign because we always go from smallest to biggest. But the question we have to ask is, do we need the equal sign underneath these or not? So if it's a filled in circle, does it get equal signs or does it not get the equal signs? Yes, it gets the equal signs. Filled in circles mean closed, and that means it has the equal sign. So we're going to put that equal sign there. And then on the 3, same thing. Right? Okay, and then our second group, or our second part of this graph, how would you describe these values up here compared to, because we're comparing it to 5, right? How would you describe these using inequalities? So numbers like 6 and 7 and 8, how do you compare? How do they compare to 5? They're greater than 5, right? So, and is 5 included or not included? Yes, what? Yes, no. Don't listen to me. I didn't mean it. Okay, well, let's start out with this. And with this one, we can just say x is greater than 5. We don't have to put the smaller one first because it's not like boundaries. So x is greater than 5. Now the question is, does this need an equal sign or not? Okay, I'm getting both answers. How do we know for sure? The open circle tells us the opposite of this one, right? This one needed the equal signs. The open circle tells us no equal sign. Okay, and then remember the really sophisticated way that we put these two together? Or we just put the word or in between them. So nothing fancy about that. You just got to write it down. Does that make sense? Looking at those pictures. So a couple things to remember. Filled in circles mean brackets, which means equal signs there. Open circle means parentheses, and it means there's no equal signs there. All right. So domains and ranges from the graphs. Since domain is the set of all the possible input values, and typically that's the x's, we're talking about left and right distances there. And then since the range is typically the y values, because the output, we're talking about up and down distances there. So when we look at graphs, that's what we're looking at. We're looking at x values on the graph for the domain. We're looking at y values on the graph for the range. Okay, so we always want to keep in mind what those words stand for. Domain goes with the x's, range goes with the y's. Okay, so here's the picture. And it says determine the domain and range of the graph below. And we're going to use interval notation on this. So domain and range. So domain is the x's. So remember with our interval notation, we always want to find the bottom value and the top value, the lowest value and the highest value. So looking at our graph here, what is the lowest x value that you see? Well, you have to be a little careful. I can't even read it up here, but it's actually x's are the boundaries right here. This is your lowest x value. Can somebody on their paper actually read what that says?
1970.
1975. Okay, so that's our lowest value. I can't read it on the graph there, so either I'm blind or it's just blurry. I'm hoping that it's blurry. Okay. And then what's the highest value that we see? And you have to be a little careful for this one because it kind of cuts off in the middle of it's not an even 5. What's the biggest value that we see there? Is it 2008, I think? Okay, is that what we're seeing? 2005 plus 3 more. So I think 2008 is our biggest value. Here's the nice thing about graphs. Unless we see an open circle specifically drawn in the graph, we get to assume closed interval. So unless you actually see in a graph an open circle, these are going to be brackets. We know the value in 1975. We know the value in 2008. That's a closed interval on both sides. Okay. Now the range. Remember, the range is going up and down. It's y values. So we do the same question. What's the lowest y value that we see actually in the graph? Yeah, is it, and again, mine is kind of blurry. Is it just a little bit less than 200? So somebody give me an estimate. 198. Okay, that's a very specific estimate. I was not even going to go for that specific, but that's okay. 198. Okay, and that's at the bottom. And then how high does it look like it goes? Yeah, 2,000 and maybe just a little bit above that, right? So somebody give me an estimate for that. 2001. Okay. All right. And again, because we don't see any open circles, what do we get to assume about this graph? Brackets. So bracket here and bracket here. Now, I will say if you watch an old video, they may have guessed different numbers for these, and that's okay. We're estimating, right? So any questions on that one? All right, I think we've got another one here. Let's try this one. So again, domain and range. Okay, and be careful because this one doesn't go all the way to the left or all the way to the right. It kind of stops. So what is the lowest domain value that you see here? 1952. Okay. And how about the highest one? It's kind of hard to line that up, but 2003. Reasonable? Okay. You might make an argument for 2002, but like I say, it's too blurry for me to worry about. So 2003 is just fine. Okay. Now on your graphs in the computer, you can click on them and they'll get big and you'll be able to see them much easier. Not like this. I can't click on this and make it big. So it's already big. It's just blurry. And what sort of grouping symbols? Brackets, because there's no open circles that we see, right? Now this one is maybe a little bit tricky. And I only remember this because I just went over this with my college algebra class in the high school class. Upper and lower boundaries. What's the lowest value that we see on our graph there? And you probably want to look at yours because it's probably clearer than this one up here.
41.
Yeah, and you have to be a little careful. The dot's a little bit above, but if you look carefully, it looks like the line actually goes all the way down to 40. Do you see that? Okay, so we get to say that that does go all the way down to the 40. Do you guys see that on the graph? So we get to say our lowest value is 40, even though there's not a specific dot there. If the line goes down that far, that's okay. Okay, and then how high does it look like this probably gets to? 88, okay. And again, we don't see any open circles, so what do we get to say for our boundaries? Brackets. And that is right, they're closed. Okay, so again, the graphs aren't too bad, right? It's pretty easy to find the domain and range there, hopefully. As long as we don't mix the two up. Any questions? All right, so we want to look at the domain and range quickly with our toolkit functions again. So domain, left and right. What do you think about our constant function? And you got to pay attention to these arrows. The arrows means that it keeps going, right? So how far to the left does it go? Forever. How far to the right? Forever. So negative infinity to positive infinity, right? All real numbers. How about up and down? How far down does it go in this particular example? 2. And how far up? 2, because it's only one value, right? It's a constant. So the domain is all real numbers, and the range is whatever constant value it's at. That's it. It's only that one value. Okay. So, and again, this is just going back to, sorry, I should have mentioned this. This is going back to that previous page. So if you want to make some notes on this, you can. If you don't want to, that's fine. But we're just kind of going with this topic with those functions to kind of try and remember them. So then we had this one, the identity function. So when we think about domain, left and right, what do you think? How far to the left? Infinity, right? Keeps going. How far to the right? Infinity. So negative infinity to positive infinity again. Now, how about up and down?
0.
How far down does it go? Yeah, do you see as it keeps going to the left, it keeps going down forever? Past me, and I can't move out of the way. And then how far up does it go? Infinity. So the domain and the range are both covering everything. Negative infinity to positive infinity, left and right for the domain, and then same thing up and down for the range. Does that make sense? And again, that's where those arrows say that it keeps going. Okay, how about absolute value? How about left and right? How far does it go left and right? What? Well, again, look at the arrows. It goes forever to the left and forever to the right still, because it's going up and out, further left and further right. Now, the range, though, is different this time because there is a boundary on the range. What is the lowest value for the range this time? 0. It never goes below this, right? And then how high does it go? Infinity. So you've got 0 with your bracket, because again, there's no open circle here. 0 with your bracket, and then to infinity. Does that make sense? How about parabolas? How far left and right? Infinity. It goes up faster than it goes out, but it keeps going forever left and right. So negative infinity to positive infinity. And how about the range this time? Yeah, again, boundary at 0, and then it goes up. So 0 to infinity. And so that's actually the same domain and range as the last one was. Okay. How about this one? Left and right goes forever, just slowly, right? How about up and down? Forever, right? So that's, again, negative infinity to positive infinity for both of those. Is that making sense? I mean, it seems like most of us are getting it, but then I'm not sure, so can't read minds. Okay, so this one's a little different, so I want to walk us through this one. We can see it goes forever to the left, right? This tells us it goes forever to the left. This tells us it goes forever to the right. But what happens here in the middle, here's my red marker. What happens in the middle is there's a cut, there's a break in this graph. It never hits an x value of 0. And the reason is because you can't divide something by 0. It's impossible. Okay? And if you don't believe me, that's fine. Try it on a calculator to give you some sort of bad error message, because you just can't do it. It's like if you have a pizza. I like pizza. So if you have pizza, I can divide it into 2 pieces. I can divide it into 8 pieces. How do I take a pizza and divide it into 0 pieces? Well, then there's no pizza anymore. But if you've got something, you can't have 0 pieces, right? Does that make sense? So there's no way to divide something into nothing. So it's undefined. So it gives us this this problem in the graph. I mean, it's not really a problem. It just disappears. So your domain then does go forever to the left and goes all the way to 0, but then stops. Stops at 0, doesn't include 0. But then as soon as you get past 0, it starts up again and it goes forever to the right. So that's where we get that union symbol in the middle. Actually, if you look at the y values, you see something very similar happens. Goes down forever, but then stops at 0, and then starts up again and goes up forever. So our domain and range, again, are the same, but one is talking about left and right, and one is talking about up and down. Get that out of the way for us. Computer writing is nicer than mine anyway. Okay, does that make sense? And the same thing, I mean, if you think about it, if you have 1 divided by whatever, that's never going to be 0, right? So that's why the output can never be 0 either. All right, the next one. What do you think about this one? It's kind of similar to the last one. Thinking about left and right, what will happen? Does it go how far to the left? Infinity, negative infinity, right? How far to the right? Infinity. But remember, we have that break at 0, right? So it's the same domain as last time, negative infinity to 0, and then 0 to infinity. How about the up and down stuff, though? It doesn't go down forever this time, does it? Where does it start? What's the lowest? What's the boundary? 0. And then it goes up forever, right? Now, do you think it ever actually equals 0? We've got 1 divided by something. We just said on the last one, if you got 1 divided by whatever, it doesn't ever equal 0. So that's where you're going to write that a little bit differently, because we can just figure out that it never actually touches 0. So the 0 in this case gets parentheses. It can't ever actually get to 0. It's above the line. It looks like it gets all the line. The space is so small, but it doesn't actually ever get there. And if I need to slow down sometime, just let me know if you're not writing something. I try and pay attention, but sometimes I miss it. Okay, so square root function, left and right. There's definitely a starting point, right? Where does it start? 0, and then it goes forever to the right. And this is more of a technical thing. You can take the square root of 0. Something times itself equals 0. It's 0, right? 0 times 0 equals 0. So you can take the square root of 0. So this is a closed, there's no open circle there. That is a closed interval at 0, and then infinity. And actually up and down, do you see there's a lowest point, again at 0, and it goes up forever, just slowly. Okay, so your domain and range, 0 to infinity, both of those zeros are closed because you can take the square root of 0, and the out is 0 at that point, is equal to 0. All right, and I think this might be our last one of this. So the cube root function, again, left and right. What can you tell me about this one? Forever left and forever right. So negative infinity to positive infinity. And then how far up and down? Yeah, same thing. Negative infinity to positive infinity because it's going down slowly and up slowly, but it keeps going forever, up and down. Okay. That makes sense? And again, we're just using the language that we just talked about to describe those toolkit functions. And we'll keep coming back to that and talking about their characteristics as we go. All right. Find the domain of each function by graphing. And I think, yes, I've got the picture here to help us out. So looking at the picture, what would be the domain of this one? Thinking left and right. Is this one on your paper?
Nope.
Oh, this one's not? Oh. Well, okay, one I guess I missed, and I tried to get them all in there. But we can still look at it. What's the domain and range of this one? Or start with domain, which is left and right. So what's the farthest to the left?
-4.
-4. And then how about the right? Well, and again, you don't see the arrow there but this one goes forever. Okay? If it goes off the screen like that, you can pretty much assume it goes forever. So what do we put there when it goes forever? Infinity. And what about the -4? Bracket or parentheses? Bracket. Do you see an open circle? Nope. So we get to assume bracket. And then how about the infinity? Parentheses, because infinities are always parentheses. All right. How about the range? What's the lowest value for the range? 0. Correct. And then how high does it go? Forever, right? So again, no open circle. We get to assume 0 is a bracket, and then infinities are always parentheses. Okay. Now there's some ways to do it with the equation, but what we're going to focus on is the graphs. Looking at the graphs. Okay. And I got another one here. Okay, so left and right. How far to the left does this one go? Infinity. All right. So and it's negative infinity because we're going to the left. And then how far to the right? Infinity. But do we see that this one has one of those weird things in the middle also? It has a break in the graph, where I read. And where do you think that break occurs? At 2. So this is where our break in the graph happens. And so we're going to go from negative infinity to 2, and then on the other side from 2 to infinity. And infinities always get parentheses, so that's going to go there and there. And because the 2 is excluded from the group, it also gets parentheses. So parentheses there and there, and then we put our union symbol in between. Okay, how about up and down? How far down? Negative infinity. How far up? But again, do we see the weird thing in the middle? Okay, so we've got that same sort of situation. And we know infinities get parentheses, so I'll put those in right away. What's the middle area this time? Where's the break in the graph this time, up and down? Right here, right? And it's 0. Does that make, I didn't even hear what you said, so it's okay. 0 and 0 and parentheses, right? Because it's not included. That's the whole point, is we're throwing out that value, so that would be zeros. Okay. And again, that's the whole idea. If you've got 3 divided by whatever, it can never equal 0. It can get close to 0, but it can't ever equal 0. Okay. All right, piecewise functions. This one is on your notes, right? I don't know what happened to those. I thought I got them all on there, but. Okay, so a piecewise function is a function that you do a different thing depending on what domain value you're putting in. So a very quick example, real life situation, and again, for some of you guys, this is an old example, but and some of you still, it is this way, at least for me it is. But when you pay for cell phone data, let's say you have a cell phone plan and you get 5 gigabytes of data with your plan. But if you go over that, you have to pay for extra data, right? So let's say your plan is $30 a month and you get 5 gigabytes of data in that plan. And then if you go over that, you have to pay, I don't know, $5 per gigabyte or something. So it depends on how many minutes you use, how much you have to pay, right? The minutes you use is like the input value, the domain. And then depending on how much you use, you have to pay a different amount, right? And they figure it out a different way. So if you're, what'd I say? 5 gigabytes? Okay, so if you're at 4 gigabytes, you pay that $30. If you're at 2 gigabytes, you pay that $30. If you go over the 5, let's say you go to 7, you pay that $30 plus some more. Does that make sense? So they change how they figure it out based on your input value. And that's what these types of functions are dealing with, situations like that. So we have more than one formula. It's not just one formula. It could be different formulas depending on what input value we have. Okay, so that's probably the best one. It used to be we could talk about phones and long distance and all this other stuff, but now all that stuff is gone because people have cell phones and nothing's long distance and all this stuff. So it changes all my examples. Okay, so let's say, for instance, a museum charges $5 per person for a guided tour with a group of 1 to 9 people, or a fixed $50 fee for 10 or more people in the group. Set up a function relating the number of people, n, to the cost, c. The first thing we want to think of is our cost is c, so let's just call that the function name, c of n. Okay, so based on the n value, we're going to figure out the cost. It's nice when the function names actually make sense, cost. It doesn't always happen. A lot of times they use f. But what happens is we have 2 different situations here, right? Our group could have somewhere between 1 and 9 people, or our group could have 10 or more people. And those are the 2 different cases that we've got. Okay, so let's write down those 2 cases. N could be between 1 and 9, and these would be equal to, because it could be equal to 1 or equal to 9. Or n could be greater than or equal to 10. Those are the 2 cases, right? Does that make sense? Let's start with the easy one. How much do they get charged if their group has 10 or more people? $50 automatically, right? How much do they get charged if they have a group between 1 and 9? 5 per person. So if n is the number of people, how do you think we would write that? Correct. 5 times n. Does that make sense? If you've got 1 person, 5 times 1. If you've got 3 people, 5 times 3, $15. If you got 6 people, 5 times 6, $30. Does that make sense? If you've got a per person, you have to multiply to figure out how much. Okay? And that's our answer. That's how we set up the equation, piecewise equation. But all that means is, depending on your input, you'll use a different scenario, different part of the function. So if you had 12 people, which part are you using, top or bottom? If you had 12 people, 12 is bigger than 10, so that would be the bottom, right? Does that make sense? If you had 8 people, which one would you be using? The top, because 8 is in this group up here, so we use the top. Okay, so depending on the input, you find which group you're in, and that tells you which of these 2 you use. Okay. All right, so let's try and do some examples of that. Oh yeah, here's my example about cell phones, which again, it's probably just about outdated because almost everybody except me has unlimited data anyway. But anyway, so a cell phone company uses the function below to determine the cost in dollars for G gigabytes of data transfer. So if the number of gigabytes is less than or equal, or less than 2, probably should be less than or equal to, but less than 2, you pay $25 a month. If you use more than that 2, then you pay the $25 per month plus, this is telling you basically $10 per gigabyte that you go over. Okay, so find the cost of using 1.5 gigabytes. So 1.5, the first question is, which group is that in? 1.5. Top, right? Because it's Less than 2? So what would the cost, what would C of 1.5 equal? I think I heard it, but I didn't. I'm not sure. 25. Yep, 25. That's included, right? You automatically get those first 2 gigabytes. But what if you used 4 gigabytes? So C of 4, this one takes more work. Is that the top or bottom? Bottom, because it's bigger than 2. So here's what we'd have to do. We have to use this function, 25 plus 10 times 4 minus 2. And this minus 2 is because you already paid for 2 of the gigabytes, right? Up there. So you're only paying for 2 extra. Does that make sense? So 25 plus 10 times 2, that's 25 plus 20, and that is 45. So that cost would be $45 if you went over with that plan. Okay, does that make sense how you figure out which one it goes to? You just figure out which group are you in. Doing this for this one, you had 3 or 4, you just figure out which group it's in first and then use that equation. Okay. All right, sketching. This is the part that can be a little tricky, especially on the computer. So I can't remember, I think I left one of these on there, but if you're sketching, the easiest way to do this is to make a T-chart. So for those of you who've been out of school for a while, I don't know what you call them. I call them T-charts, but anyway. And that T-chart is based on input and output values. So the boundaries are given over here. One of the boundaries is this 1, and then the other boundary is this 2. Does that make sense? It's the ones listed over there. That's breaking your domain into parts. Okay. So here's what I have had my students do in the past is I put in the boundaries. So I want a boundary at 1, and I put that 1 in there twice, once for this one and once for this one. And then my other boundary is at 2. So I'm going to put that in twice, once for that one, and once for that one, and once for that one. Okay. And then to fill out the rest of the T-chart, I want some numbers that are less than 1. So and keep it close to 1, but what are some numbers that are less than 1? 0 and -1. I mean, that's enough. We don't need very much. We just need a couple. There's actually no really nice numbers between 1 and 2, so we're just going to leave it as 1 and 2. They're right next to each other. How about numbers that are greater than 2? 3 and 4? Yeah. Right? Yeah, we don't have to make them complicated, just something close. I just keep them all right together. Now, these top ones, the -1, the 0, and the 1, which function do they go with? The top one, right? Because these are the numbers that are in this group. So this is the top, and I put them in order when I do it because it's easier that way. But the middle ones are for the middle, right? And then the bottom ones are for the bottom. So if you set it up that way, it makes it pretty easy because then you've got that. So when I plug this -1 in, I'm using this function, right? So -1 squared, and we've already done this tonight, but what is -1 squared? +1? Because a negative times a negative is a positive. How about 0 squared? This is your turn. 0, right? Okay, and then 1 squared is 1. I gotta move this thing. It's not in a good spot. Okay, so that's the first ones. And I'm actually going to draw that right away. So my points are, the one thing I want to look at, because this has the equal sign on it, what does that mean about this point right here? What did the equal signs tell us when we're talking about graphs? It's a closed circle. Okay, so that's going to be closed. The boundaries are the only ones you have to worry about open and closed. Everything else is just going to have a line going through it or a curve. So 1, 1, this is x and y points. So x is 1, y is 1. That's right there. And then 0, 0 is right here. And then -1, 1 is right there. Okay, now another thing that I'll do sometimes just to help visualize this is I will draw my boundaries on here. So my boundaries at 1 and my other boundaries at 2, they're pretty close together, but these are the two boundaries. Nothing can go across those lines. Okay? So I know that this is my boundary right here, my boundary point. It's going to go down, touch that, and it keeps going that way, but it can't go past that red line. That's where it stops and switches to a different function. Okay, so I'm going to switch colors here so we can kind of visualize this. Let's go with green. In the middle function, if I put in a 1, what is the output? Don't make it complicated. It's 3, right? Because it's a constant. It's just always 3. So this one is 3. And what is this one going to be? 3, and everything in between there's 3. Everything's 3. And remember our toolkit functions, constants are horizontal lines. So this is going to go, oh, is this going to be on this side with the 1, is that going to be an open or a closed circle? Is there an equal sign? Nope, so that's open. So that's an open circle at 1, 3. Okay. And how about this one? Will this be an open or a closed circle at the 2? Closed because of the or equal to. So this one will be closed. So that's going to be closed right there at 2, 3. And then we know it's just a horizontal line between them. And then again, it stops at the boundary. It doesn't keep going. Okay. And then let's see, I've got blue. Let's see if the blue will work. That's purple, by the way. Just so you know, I am using all 3 different colors. Oh, we'll use black. It'll be easier. Okay, the bottom one. And we're using the bottom function. So if we put in a 2, it's using this equation, 6 minus 2. And what is that? 4. And if we use a 3, it's 6 minus 3. So that is 3. And if we use a 4, 6 minus 4 gives us 2. And again, the boundary one we have to look, is this to be open or closed? How do we know? There's no equal sign, so that means open. So at the ordered pair, 2, 4. So 2, 4, this is open. And then again, the boundaries are the only ones you have to worry about that. The rest are just points. So 3, 3, 3, 3, 4, 2. It starts here at the boundary and it's going to go this direction. Okay. So that's how you would make a graph. And I would suggest, I think you've got one on your homework that you have to do this, but I think they're straight lines, so it's a little easier to make. But I would do the T-chart first so that you know what your points are going to be before you try and draw it with the tools that are on there. Okay, so for something like this, I think you got something like this, you'd use it's a ray tool. So it's going to be a tool that looks like, and it has an arrow on one side, but not on both sides. Then the middle section would be a tool that looks like this. It just, there's no arrows on either side. So just be careful. And again, if you need some help, I think there's like a button right underneath there to help you with a tutorial of how to draw them too. So you will be happy to know that when we take the test, it's on the computer, so you just draw them in real life on a piece of paper, and I will look at them, not the computer. So, but that's the end of 1, 2, and so it is about 6:20 right now. And that one has 9 problems. So again, those homework problems, yes, they are graded, but the key thing for me is that you're doing them as practice to get you ready for when you eventually will have to take a test. Okay, so don't be scared to ask for help from each other, from other people, from me, whatever. Don't be afraid to do that. And in fact, there's even videos on there that will sometimes show you how to do the problems if you look at them.